Welcome to the lesson on Object-Oriented Programming, OOP, Fundamentals in C#. In this lesson, we will dive into the core principles of OOP, which are essential for developing robust and maintainable software. Understanding these concepts will empower you to design your applications effectively and leverage the full potential of C#. Don't worry if this feels new at first. This section covers what's object-oriented programming. Object-oriented programming is a programming paradigm that uses objects to represent data and methods to manipulate that data. An object is an instance of a class, which can contain both data, attributes, and functionality methods. OOP allows programmers to create modular and reusable code, making it easier to manage complex software systems. Now, core principles of OOP. The four main principles of OOP are: first, encapsulation, also inheritance, also polymorphism, finally abstraction. Encapsulation is the bundling of data and methods that operate on that data within a single unit, usually a class. It restricts direct access to some of the object's components, which helps to prevent accidental interference and misuse of the methods and data. This is typically achieved using access modifiers such as public, private, and protected. Now we're on example of encapsulation. This slide introduces a class definition. Study the structure in the code sample. In the example above, the balance field is private, meaning it can't be accessed directly from outside the bank account class. Instead, we provide public methods to deposit money and retrieve the balance, ensuring that the balance can't be modified directly. Inheritance allows a class to inherit properties and methods from another class. This promotes code reusability and establishes a hierarchical relationship between classes. The class that inherits is called the derived class, while the class being inherited from is called the base class. Next, example of inheritance. This slide introduces a class definition. Study the structure in the code sample. In this example, the dog class inherits from the animal class. This means that a dog object can use both the eat method from the animal class and its own bark method. Polymorphism allows methods to do different things based on the object that it's acting upon, even if they share the same name. This can be achieved through method overriding and method overloading. Example of polymorphism, let's dig in. This slide introduces a class definition. Study the structure in the code sample. In this code, the method makeAnimalSound accepts an animal object and can invoke different sounds based on the actual type of the animal passed to it, demonstrating polymorphism. Abstraction involves hiding the complex implementation details and exposing only the necessary features of an object. This simplifies the interaction with the object and reduces complexity. Now we're on example of abstraction. This slide introduces a class definition. Study the structure in the code sample. Here, the shape class is abstract, meaning it can't be instantiated directly. The circle class provides a specific implementation for calculating the area, thus abstracting away the details of how the area is computed. In this lesson, we explored the key principles of object-oriented programming: encapsulation, inheritance, polymorphism, and abstraction. Each principle plays a vital role in creating clean and efficient code. By applying these concepts, you can improve the design and maintainability of your C# applications. Alright, your turn. Give this a try. First, create a class called car with properties for make, model, and year. Include methods to display the car's details. Also, implement a derived class called electric car that inherits from car. Add a property for battery capacity and a method to display its battery status. Finally, demonstrate polymorphism by creating a method that takes a car parameter and calls its display method.